In this video, we are going to record a case study of using decision tree to evaluate the credit risk in SPSS. A bank maintains a database of historic information on customers who have taken out the loans from the bank, including whether or not they repaid the loan or defaulted. It means we have a class variable whether the customer repaid the loan or defaulted. So it is a binary variable, and this class variable exists in the data file. Using a tree model, we can analyze the characteristics of the two group of customer and build a model to predict the likelihood that the loan applicants will default on their loans. The different attributes are there, like education of the customers, the age of customers, and we have a class variable which is the whether the customer repay the loan or defaulted. This is the class variable which we can use to predict. In this case study, we will use a data file that is available in the tree credit.sav. This is the file name, and this file name is available in the IBM SPSS sample files folders. These folders are available in the installation of IBM SPSS 20 or 21, whatever version you are using that. What fields are available in this data file? That fields are, I'm showing you the data file in that contains all of the different attributes to predict whether the customer will repay the loan or default it. In this data file, we have 6 variables. The variable 1 is the credit rating, is a numeric variable, and this numeric variable has 2 values. 0 means the bad credit, means defaulted, or 1 means the good credit rating. So credit rating is a class variable that we will use in this analysis, and further predictors are about age, income, credit cards, uh, how many credit cards the customer has. 1 means the less than 5 credit cards, 2 means 5 or more credit cards. So this is also a binary variable which has the 2 values, 1 and 2. The next thing is the education level. Education level is 1 for the high school and 2 for the college education. And another variable we have car loans. Car loan 1, none or 1, and 2 stands for the more than 2 car loans the customer has. One variable is the variable income. Is one of the important variable. It has the 3 levels. 1 means the low income, 2 means the medium income, and 3 means the high income. So this is the data file. In this data file, we have one variable which is named as a classed variable or a dependent variable, and all of the rest of these variables are independent variables. So these are the 5 independent variables and 1 dependent variable we have. We can predict credit rating with the help of these predictors. The classification algorithm calculates the information gain for all of these 5 predictors, and the predictor which has the highest value of information gain will be used first to bifurcate the tree, or we use the first important predictor for credit rating. So we implement the procedure in SPSS. SPSS calculate the credit information gain for all of these 5 variable and decide which is the most highly predictive power of these independent variable has, which we can use for the prediction of the credit rating. The data file contains these values. Credit rating 0 means the bad rating, and the credit rating 1 means the good rating. So we have the 2 types of customer, the bad rating customer and the good rating customer. The age is a purely quantitative variable. Income as 1 and 2. Credit cards, you can see 2 cards. Education level 1, 2, these are the 2 education level, and car loans 1 and 2. So these are the different variables we have. These variables are created and categorized with the help of class labels. Class labels are basically the different coding schemes are used to code these variables. To recode into different variable, recode into same variable. These are the different techniques in SPSS by which we can create these type of variable. So age is a pure quantitative variable, while other variables are basically the recoded variable, which are coded into 1 or 2 levels. So as you can see that the income is divided into the 1, 2, and 3 in the 3 levels. 1 means the low value customer or the low income customer, 2 means the medium income customer, and 3 means the high income customer. Means this is the customer which has a very high income. So this is the data file, and we will use this data file to implement decision tree algorithm and decide which out of these 5 predictors has most predictive power to predict the credit rating. So this is the procedure that we have to run. I am directly implementing this into the SPSS case studies. So you have to move to the SPSS help. You have to move to the SPSS help. This is the help, and then case studies. From the case studies, you have to click on the base statistics. From the base statistics, you have to click on decision tree. Decision tree. Instead of going to the base statistics base, you have to click on the decision tree options. In the decision tree option, the first is decision tree, and in the decision tree, we have credit risk. This is the third option in the decision tree options. Using decision tree to evaluate the credit risk. When you click on that, you can move the window to the left or right. So this is the information that I already read in the first slide, and then you have to click next. After clicking treecredit.sav, this is the file which is used for this case study. Now click next. Now creating the model. The decision tree procedure offers the several different methods for creating the tree models. For this example, we will use the default method. The CHAID method is the chi-square automatic interaction detection. Chi-square automatic interaction detection means this will use the chi-square technique to obtain the highest power highest predictive power independent variable. So out of the 5 independent variable, the CHAID algorithm will decide which one will have a most predictive power to implement the tree. So the CHAID algorithm we have to choose. Now, how to run the procedure? You have to click on analyze. From the analyze, classify, and the tree. So these are the 3 options that you have to click. The first option is analyze. From the analyze, you have to click on classify. From the classify, then you have a tree option there. To click on the tree option, you will get the output. You have to pick the dependent variable from the list of variable. Your dependent variable is the credit rating, and all of your independent variables are in the independent variable dialog box. So the five variables we have here: age, income level, number of credit card, education, the car loan. So these are the five variable, and one variable is a dependent variable we have. And the growing method is CHAID. This is the chi-square technique. Chi-square technique will be used to obtain the more highly predictive independent variable out of this list. Now selecting the variables, and then at this point you can run the procedure and produce a basic tree model, but we are going to select some additional outputs and make the few minor adjustment to the criteria using the generate model. So what you have to click, you have to click the criteria. This is the button which we have to click. If you click the option criteria, so you will have categories. So from the categories button, you have to select what categories do you have. So bad and good. So these are the two categories that you have to choose. So click on the bad and click on this arrow. So this bad credit rating is basically the focus of this analysis. Then click continue. After that, you have to click on minimum number of cases and the child nodes. So we have to click on the criteria. In the criteria, we can choose the parent nodes. The maximum number of nodes we should have 400, and the child nodes are 200. So this is the criteria that we are using, maximum level we are using, so that at any time if the tree needs more branches, so we have a maximum limits of these branches here. So just adjust the minimum number of cases per group, 400, and the parent nodes, and 200 for the child nodes. Click continue. In the output box, you have these options: the tree, the statistics, the plots, the rules. Now you can see top down, this is the orientation. Node tables will be displayed, and reduce scale for the large trees. You can select the various type of additional outputs, independent variable, statistics, node definition, trees in tabular form. If you want to see the trees in the tabular form, just click this, otherwise remove this option. Now in the tree in the table form, you have to check that because you want to see the outputs in the tabular form. Now click on this plot button. If you click on the plot button, you will get gain and index. The gain and index, these are the two quantities that will be calculated in the plot segment. To just check these two boxes. After that, you have to specify, in this example, the plot tab is not accessible until after you have specified one or more the target categories. As we initially have the target bad as a target categories. So if you do not choose the target category, then this plot segment will not be shown. The plot segment is only be shown if you have choose the target category. Click continue. You can save the variable contain the information in the model. For example, you save the credit rating predicted for the each case and compare those prediction to the actual credit ratings. So you can, in the main decision box tree, click save. Actually, this option will be available in the main option, in the main window. So you have to click on the save output. Then terminal nodes, decision tree, saving procedure, terminal node numbers, and predicted values. The predicted values will be saved as well as the terminal node number will be saved. So these two outputs will be saved in your data file. Click continue, and in the main dialog box, click OK. This button is to be pressed. Now the model is going to evaluate. For this example, the model results include the tables, as I choose the tabular form of the tree diagram itself, the charts that provide the information about the different predictive powers of the variables, model prediction variable added to the active data set, because in the save option we choose that. So these are the four different outputs we can see in this model. Now this is the first output. This, in the summary table, we have what? We have 400, maximum parent cases are 400, and the node cases are, and the child cases are 200. So maximum tree depth is 3. And 5 variables are used as an independent variable: age, income, credit card, education, car loan. These are the 5 variables, but the result shows only 1, 2, 3, 3 of these independent variable are having the most predictive powers. So the remaining variable are eliminated from this model. What that variables are which are eliminated? The age, income, and credit card. These 3 are used. Education and car loan is eliminated. The number of nodes are 10. The number of terminal nodes are 6. The depth is 3. And this is the summary statistics. The method, chi-square method, is used for obtaining the most predictive independent variable. Now 3 variables are used, as I told you. This is the tree. So you can see the tree. In this tree, this is the root of the tree, and the root of the tree is indicated that 41%, 41.39% customer has a bad credit rating, 58% has a good credit rating. Means we can say that 0.58 is the probability of having a customer having good credit rating, and 0.4139 is the probability of out of the different variable. We can see that out of these different variable, income level is the next predictor. So credit rating is the main dependent variable, and income level is the first independent variable that is used. Low income, less than or equal to the low income, so we have this node. If we have above the, because this is a half open interval, the right side we have a square bracket, on the left side we have a round bracket. It means the income more than the low and is equal to or less than the medium. So this is basically the medium income level group. And the third one we have greater than the median income, which is the high income group. So a high income group, the median income group, and the low income group. So this is categorized. So the income level is the highest level predictor that is used first. So we can say that 82% of the customers who has the low income has a bad credit rating. It means if we gave the loan, if the bank gave the loan to the customers whose income is very low, so there is a high probability of bad loan. And 17.9, it's about 18% of the customer who has the low income or the below low income has a good credit rating. So the high probability of getting the bad loan of the customer if their income level is very low. Medium income, 41.9% of the customer having the medium income bad credit rating. 60%, about 60% of the customers who has the medium income as a good credit rating. If the income is high, then only the 11.5% customers have a bad credit rating and 88.4% has a good credit rating. So there are 90 such customers who have a bad credit rating with the high income, and 687% cases in the data file we have which has a high income. We can have the different numbers here. Total medium income customers are 31.5. Total high income customers are 31.5341%. So this is the percentage of total high income customers. So 777 out of 2,464 customers. So out of 2,464 customers that we have in this data file, 777 customers have a high income level and the percentage is 31.53%. So you can see the numbers as well as you can see the percentages of the bad and good loan credit history. And we can verify that if we add 777, 11134, 5553, so this number will be completed. 2464, that is the number which will be verified. If we add 22, 46, 31, the 100% will be completed because this is shown as a 100% customer. So this is not a terminal node. This is not a terminal node, but this is a terminal node. Terminal node means what? There is no further sub branches of below low income customers. So that is the ending of this tree, the tree level. Now the customers having the medium income, the number of credit card is the second highly predictive powers. And in case of high income, the number of credit card is also. So it means the second level of predictor is the number of credit card in the both of the cases. Either we have a high medium income or we have a high income. The customers who have a number of credit cards 5 or more, so we for the tree is further splitted and less than 5 customers we have here. So 13.84 we have a bad credit rating. If we have a number of credit card less than 5, so the high percentage of customers are paying the loan. If the number of credit cards are more than 5, it means there is a high probability of risk. So 56.72% of the customer have a bad loan if they are maintaining the more than 5 credit cards. In the high income group, we can see that more or less opposite thing we have here. If the customers have a 5 or more cards, bad rating is 17% and the good rating is 82%. So there is a high change in that. But that is the same categorization in between the more than 5 cards or less than 5 card. So that customers are very low. These are 3% only who has a bad credit rating, and high income, the number of cards are smaller than 5, the bad rating is 3 and the good rating is 96. Means about all customers, almost all customers are paying their loans if they have high income and the number of credit cards are less than 5. So mostly almost all customers are paying their loans. So these are only the 322 customers. Then these are to the terminal nodes as well. This tree is not further bifurcated. Now if the customers have a more than 5 cars and their income is medium, that is further branches with the age. The customer who has a smaller age is again at the risk. 80.84 means the youngsters who has a medium income, the number of credit card high, the age is very low, there is a high probability of default, bad rating. This is, and this is the good rating. So this is the way of analyzing the tree, which the chi-square algorithm will decide at every level which of the independent variable have high predictive power. So income level, then we have a number of credit card, then we have a age. So these are the 3 levels. The total depth of the tree is 1, 2, 3. The depth of the tree is 3. As we have total 9 branches of this tree, this is node number 9, which is a terminal node. This is node number 8. Each node is labeled by the node number. In tabular form, these node number will be shown. So in the next slide, we will have the node numbers with these percentages. So in the tabular form, because we have chosen the tree tables to be shown in the output. So these are the different nodes, 0, 1, 2, 3 up to 9. These are the 9 nodes. And the number of customers for the bad rating, it is 1024 with the percentage, and the good number of good rating, number of customers having a good rating at node number 0, 58. If node number 0 is indicating the root of the tree, I mean, that is the total number of the customer will be 1444 plus 1020. So if we add these two good or bad rating customers, then we have a total number of customers in the table. So this is a very important table, but this table is not new. It is just a reflection of this tree in the tabular form. All of these percentages and all of these numbers are represented with the help of the table. So the table plays a very important role in analyzing the output. This table is an important table. It shows the chi-square values with the p values, which is given in the second column, along with the degree of freedom and the split values. So income level is the first variable, which is bifurcated into 3 levels, and then number of credit card is in the 4 different nodes, and 2 different nodes we have for age. Each level or each independent variable has a very small p-value, which means that all of these variables are significant. So it means the insignificant variable are not shown here in this table. The significant, all values are significant. But chi-square values, the greater chi-square values indicate that these variables are have very high power of prediction. 662, the value of chi-square income level, and 662 and 662. So it means the income level is a very high power of predictions we have. Then after that we have 193. These 2 levels have a very high prediction power. Then these are smaller than 100, less power we have for prediction. So these are the degrees of freedom. The split values are smaller than this square bracket is indicating that equal to the medium income, but more than the low income. So this is basically a median income group, and this is the greater than median mean. We have a high income group. So income group is split into the 3 levels: the low, the medium, and the high income groups. These are the different values by the shade method, the degrees of freedom, the significance value. The most practical purpose, this is to have the significance level. Significance level means the p-values. This is value 1 in the round bracket and value 2 in the square bracket, indicating that more than half open interval, more than value 1, but less than or equal to value 2. So this interval can also be represented with the help of an inequality. This is indicated as the income is greater than value 1, and this is the income level, and smaller than or equal to value 2. As we have income is a categorical variable, and we have only 3 values for that: income level 1, income level 2, or income level 3. So value 1 is low income, and value 2 is the medium income, and value 3 is the high income. So but this is indicated with the help of half open interval. The gain table indicate that the terminal node 1, 8, 9, 6, 5, 7. These are the terminal nodes, and these are the percentages: 44% gain, 20% gain, and 1% gain. So these are the number of cases in node number 1, number of cases in node number 8, 483 cases in node number 9, and so on. And the indexes is indicating the node percentages, and then the gain percentages and the responses. For categorical dependent variable, the response is the percentage of cases in the node in the specified target category. In this example, these are the same percentages displayed for the bad category in the tree diagram, because we have chosen the bad category as a response variable. Now the index values is basically an indication of how far the observed target category percentage for that node differ from the expect percentage for the target category. So that is an index value. The index value, high index value is indicating that the number of cases we have, high number of cases we have. If the index value is greater than 100, means that there is a more cases in the target category than the overall percentage in the target category. So more cases in the target category as overall cases in the target category. This is a more than 100 indication. And we have a smaller than 100. Conversely, it is indicating that there are the fewer cases in the target category than the overall percentages. So now the target category bad and the gain chart is shown. If we have chosen the target category, then this chart will be shown. Otherwise, if we have not chosen any target category, then this chart will not be shown, and this option will not be available in the output. This is a good indication if cumulative gain charts starts from 0 and goes to the 100, and if it is above the line, which is the diagonal line, then we have a good model. So this is an indication of a good model. Similarly, in the index chart, this is an indication of a good model. So we have to be started from maximum value and goes to the 100%. So this is an indication of a good index chart. Now, the risk and the classification. This is very important table. The risk is 0.205. Risk means what? The misclassification. As I already shown the misclassification and good classification in the slides. So the misclassification is 0.205. It means out of all cases, 20.5% cases are misclassified. Means they are wrongly identified. Suppose they are the good customer but classified into the bad category, or they are the bad customers but they are classified by the model into the good category. That is a misclassification rate. These are the true values. You can see the true values are what? True positive and true negative. So this is the true positive TP, and this is true negative. I think I'm true positive and true negative. So these are the two options. Or this is false positive. This is false negative. So these are the different percentages. So we can calculate the good classification rate with the help of these information. I'm showing you the table in the PowerPoint slide where these numbers are represented earlier whenever I was describing the classification trees. This is the accuracy of the classification model. You can see that true positive, true negative. These are correctly classified items, and these two are the incorrectly classified items. So we can calculate the accuracy by TP plus TN divided by the all cases, and true positive rate can be calculated by TP upon. So these rates are represented in that table. Uh, so this is correct classified items. These are the correctly classified item. These two are the incorrectly classified item. So along with these two misclassified items, the percentage will becomes the 0.205. This is the probability of misclassified item, and 20.5% items are incorrectly identified. The method is chaired, and the dependent variable is the credit rating in this case. The overall percentage for correct classification is 79.5. It means 79.5% items are correctly identified by this model. As in the options, I choose save button. So the save button will create the 4 new variable in the data files. These 4 variables can be seen here: predicted probability 2, and node ID along with and predicted value. So this is the predicted value, and so these 4 new variables are created in my data file, and that is saved into the data file along with the actual data we have. So this is the output, and you can see that the predicted probability is simply the proportion of cases in the each category of the dependent variable for the terminal node that contains the each case. For example, in node number 1, 82% of the cases are in the bad category and 18% are in the good category, resulting in the predicted probability of 0.82 and 0.18 respectively. So you have to proceed to the in the same way to the end in this case study, but initially I represented the case study, how you have to implement this case study into the SPSS, and what are the outputs and how can we interpret the output, how can we decide which variable has a high predictive power and which variable do not have the high predictive power. So this is not the end of the case study. We have the further slides in that. We have further amendments and modification in this analysis. But I am terminating this recording here, as this is the first phase of decision tree prediction in credit rating. Thank you very much.